All right, so we figured out how to calculate A1 and B1, and you should be able to use that understanding to calculate our C1 over here. And you want to make sure you can do that. So you should, try it out on paper and make sure it works. Now let's see, how does that translate into making 50 spirally triangles here. So I guess, well, one of the things to note is that this calculate next vertices is happening over and over and over again. So let's just take a look real quick again at what we had here for our first inner triangle. One thing to note is that, let's see, these triangles, if we look at this triangle right here at ABB1, this triangle here, we know that, and this is with Q equal to 1/4. So we know that this is 3/4 of the side. We know all these outer side lengths are equal because we made it to be an equilateral triangle. We know that this is 3/4 of a side and this is 1/4 of a side. And we know that all these angles are all 60 degrees. So all these angles, angle B is equal to angle C is equal to angle A. So what we have here is a side angle side. If you're familiar with that in geometry, then you'll recognize that that means that this triangle is congruent to this triangle, is congruent to that triangle. If you haven't gotten that far in geometry yet, don't worry about it. Basically, all I'm saying is that this triangle and this triangle and this triangle, these three triangles around the outside are all the same size, and that can be verified through geometry. And what that means is that all these red lines are exactly the same size. So we've made another equilateral triangle inside this equilateral triangle. We've verified that we can use all these calculations to find our A, B, and C, pretty much. Okay. So the next, how does this continue to make all our 50 triangles? Okay, well, notice this call to calculate next vertices is happening inside a loop, and it's looping 50 times, so we've seen that already. Let's take a look down here at calculate next vertices again. So the first part is our setup part, right, to say all our A1, B1, and C1 values. And then the next thing that we do is whatever was formerly in XA1 gets assigned to XA. So XA gets a new value that was the XA1. XB gets the value that was XB1, and so on. So what does that look like? That looks like this. Okay, so now what's happened is this used to be A1, now it's A. Okay, now this is XAYA. This point that used to be B1 is now B. Okay, that's what all these assignments are doing. Okay, and this point that used to be C1 is now C. Okay, so we've renamed all our vertices in that step. And then what happens? Well, then we come back out. We draw that triangle. Okay, so we've calculated the next set of vertices. We draw that triangle with all our assignments, right? And then we're looping through again and calculating vertices again. So then we do the next step of calculating our next set of vertices. And our next set of vertices, now we're starting with these. We can use our same formulas to find the midpoint between this A and this B. That's our new A1, right? Between B and C, that's our new B1 here, and then we calculate this one. And so then we're able to draw another triangle inside of it. And So we can do that and just keep going and going and going. Because we're looping through, we keep recalculating and redrawing and recalculating and redrawing. And that's how we're able to get 50 of these guys. Let me just see if I still have it set up to draw 50 here. Okay, so now let's set the triangle count to 50. Back the way it was. Make sure my ratio, yeah, my ratio is 0.05 again. So now I'm because I want to make my rotation smaller, and I think that's all I needed to do to fix it up. Let's just make sure the code is still working, and yes. So there's our whole bunch of triangles, and basically, and it's now we know exactly what's going on here is that we're making smaller and smaller triangles and rotating them, and that's what makes this cool shape.